everyone, welcome back to STEM for Others. So, last time we were getting more into what machine learning is, everything about it, and now we're actually going to be applying it. So, we're going to be learning how to code an AI algorithm with all of the knowledge you've already learned. So, some of this initial slides should be review of what you already learned in the past lessons, but the very first big thing that we want to do when we're deciding to code an AI algorithm is to choose your problem. So first of all, you're going to choose what you want to do. So say you want to do a detection of dogs versus cat images. So if that's your whole idea, then you're going to go and find your data set. And I encourage you, when you find your data set, to look for something that is free. There's so many sources online, so try to find something that's free. Try to find something without bias, so there's like an even amount of data for each thing that you're trying to classify. Try to make sure that the data is from a good source. And once you've found all your data, you can put it in an Excel sheet, a spreadsheet, a number sheet, and try to convert it down to a numerical value. But then once you have all your data ready, we can start with choosing our problem. So we want to see if we want to do a regression problem, a classification, a clustering, which is kind of like a classification problem, and a deep learning problem. So deep learning is essentially something that regression and classification can fit under, but we're going to look at these as a bit separate because there's different models for each. So regression, some algorithms include linear regression, decision tree regression, and random forest regression. So these are some different models you can look at. Some algorithms for classification include logistic regression, k-nearest neighbors, and random forest classifier. For clustering, some algorithms include k-mean clustering and hierarchical clustering. And then for deep learning, you can use neural networks, CNNs, Keras sequential models. There's a lot to look at. And these are just some to start. You can always look up these and see if they fit your data well, but then you can also look up more. So some popular ones used for classification. Number one, logistic regression. So this uses a logistic function to create a binary output. So classification is all about giving a binary output. So then k-nearest neighbors is cluster based on proximity of certain data points to one another. Random forest is composed of many decision trees in training and combines these outputs in model execution. And then a decision tree, this is part of what random forest has, and it breaks data into small samples for binary classification. And then some popular ones for regression. So your model is usually going to be a classification or regression. It just depends if you want to apply deep learning to that. If you don't want to apply deep learning, that can go either way. And then also if you want to do something with clustering, that's more of a classification problem. And then linear regression, this establishes a best fit line for data. It's a very simple model. Polynomial regression is an extension of linear regression for nonlinear data. And then random forest regression, KNN regression, and decision tree regression. So these are the types of models that we use in classification, but they're tweaked to predict values instead of forming binary outputs in clusters, so it's not actually doing a classification, it's giving you an actual value for your regression. So some important steps for initialization of your data. So after you refine the question, the data needs to be collected. Ensure your data fits machine learning training and testing. Check for any bias or sways in data set to receive more accurate and authentic results during testing. So Google Colab is a place that I mainly use for coding. I really recommend it. It's great for any sort of algorithm application. So I recommend you use that too. So in Google Colab, a commonly used platform or model for model evaluation, you can either upload your data as a file or through your personal Google Drive. So code for the uploading data from a Google Drive is right here. So just ignore the hashtag. So basically what a hashtag is it I forget the word. Oh, it comments out your data, so, or it comments out whatever that line is saying. Sorry. So a hashtag will basically act as a comment, and it could just give, it's like a little note for your code telling you what you're doing. This can be helpful if you're looking back at your model and seeing where is this, I want to know how I did this. This can be really helpful, and all you do is put a hashtag in front of your line of code, and it basically doesn't register to the model, so that part won't run, but it will still be there in your coding cell. So you can upload from google.colab, import drive, and then from drive.mount, and then have your content g/g drive. So you're basically going to want to implement your data, whether it's in Excel or numbers, and put that somewhere, store it in your Google Drive. And then you can just call upon it using your Files tab. And then from upload data from files, you can use from google.colab, import files, uploaded equals files.upload, then select a file. I'm going to make a video actually going through all of these steps, so don't worry if you're confused, but if you know how to code and this doesn't seem like that too hard for you, I bet you could use these pieces of code right here to start on your own. So visualization and cleaning. So we're actually just going to talk about a little bit of visualization today. So visualization, once your data set is loaded in, it's important to visualize the data to scout out any NaNs. So these are non-existent values and non-consistent data points. So that is what you're using to clean. Code. So here we comment out visualize data set. So df.head, where df equals your data set. So you can make df into data set, the name of your data set. If you're doing like cat pictures, you can put cat pictures as df. It's really whatever you want to set that variable to. I recommend something like df data set. Something that doesn't take that long to write out is really good. But you want it to be specific so you can, when you're looking back in your code, you can see exactly what you're using. And then some very simple ways to visualize your code or visualize your data set once you've loaded in your data is through a scatter plot or a histogram. So scatter plot is here on the top, and you can see this is the code for scatter plot. So you want to first import your library. So from matplotlib, from matplotlib, we're gonna be importing our pyplot, and this is just your scatter plot here. So this data is actually not consistent with the graph. The graph is just to show you this is what a scatter plot would look like, possibly. This code here is not anything in specific, so it's just showing if you had a data and then you cleaned your data and called it data cleaned, and then you use data feature 1, so whatever your first feature is or whatever feature you want to test in the model, this is basically what is going to come up on your scatter plot. This even though it's not consistent and this isn't a real data set, this is just an example. So maybe your scatter plot could look like this of your first data feature, if that kind of makes sense. And then on the bottom, we have the code for a histogram, which is a bit different. Instead of being little dots and scatters of dots everywhere, we're going to have some bars. So it's basically a bar graph. And then this is the code for the plotting the histogram, and it's the same thing if we had a data and we called it data cleaned, and then we used the first data feature. So you can name these variables anything, just make sure they are already existing in your data in your notebook, so that when you run this cell, it will actually load through. So that's all for today. We're gonna go through some more code next week, and then I'm gonna make a video going through everything that we learned for how to set up a model. And so you can watch that video and check your code. Maybe you don't understand some things, so you want to go over it. But I hope you learned something. And if you have any issues with the code or you're finding it difficult, there's many videos on YouTube, and I also recommend looking up these libraries to see the exact code. because those guides are very helpful. Thank you so much. Bye.